Hello, everybody. So what we're going to be looking at today is section 13.2 in your book, which is finite state machines. Now, we weren't in chapter 13 previously. We are skipping around in the book a little bit to make sure we cover the topics that we're supposed to cover in this class. So with that said, let's go ahead and get started. So finite state machine, what's the deal there? So a finite state machine, or rather, um, let's see, many, this is according to your book, many machines. And when we say machines, that could be like um, things in hardware or software. So we're using that word machines a little bit loosely there compared to how you may have used it in the past. But many machines, hardware, software, um, can be modeled with a structure that we call finite state machines. Finite state machine. Okay, that's a little bit awkwardly worded, but I'm not going to rewrite it. So that's great. So it's a model for a machine. What does that mean? Well, um, they use a vending machine as their example, and I may as well do that too. So this vending machine model, we start out with the vending machine model, even though it's kind of really a lot more complicated than all of the other models that you're going to see in this section. So if this is, going to look complicated initially, then don't worry. This is the most complicated thing. So example, vending machine. All right. So they describe a vending machine, how it's going to work. So here's what they say. So they say we have a vending machine. It can take money, right? So you know how a vending machine works. Everybody knows that, right? So we put in money, we get things out. So this is how this particular vending machine works. So it can take nickels, dimes, and quarters, right? Takes uh 5, 10, 25 cent coins. Now, I know that they're called nickels, dimes, quarters, but we're going to label them 5, 10, 25. So let's just say that now. Takes 5, 10, 25. Um, let's see. If the total in the machine is ever over 30, machine is ever 30 or more, or just 30 more than 30, 30 cents, then what it will do is it will refund you down to 30 cents in the machine. So it refunds your money down to 30 cents left. I do not like how I said that, so I'm going to rewrite that. Uh, it returns the money in excess of 30 cents, right? So if you have a quarter, if you have 25 cents in there and you put in 25 cents, then it will just give you 20 cents back so it can stay at 30, right? So it doesn't want to stay more than 30. So it refunds anything over 30. All right. Now, when you have 30 cents, um, 30 cents in the machine, the user can press a button. They can press an orange button to get orange juice, or a red button to get an apple juice. All right, and that's pretty much it. And so those juices cost 30 cents. And so after you do that, you'll be down to 0 cents. And then that's how the vending machine works. Now, you can do this kind of machine, like this kind of logic here, can be done in terms of like circuits, right? It doesn't have to be done in terms of, complicated software. And in fact, you wouldn't want to use complicated software probably for a vending machine because, complicated software has a lot of problems. And one of the advantages to using these finite state machine representations of things is that you are being very careful controlling um, where and how the machine can transfer from one state to another state. Okay, we haven't even talked about states. We're going to talk about them now. Um, so the idea of how this might work is something like this. So, um, so let's say you go up to the machine. So, how it works. Example operation. All right. So you can walk up to the machine, right? You could put in, um, you walk up. Step one, that says wake up. Wish I could. Walk up to machine. Not really important. Okay. Step two, what are we going to do? We are going to put in a dime, right? So we put in 10 cents. Put in 10 cents. Okay. Now you're going to put in 25 cents. So you put in 10 cents, you put in 25 cents. Now you put in a total of 35, right? So what should happen? So what should happen is because there's 35 cents in the machine now, the machine should refund you 5 cents. So machine uh, returns 5 cents. So now there's 30 cents left in the machine. With 30 cents left in the machine, it expects you to press a button. So let's see here. We're going to press a button. Press orange button. I don't know why I looked at the book to see what button you press. Doesn't matter. Press the orange button. So then the machine should, uh, give you an orange juice. Right? Um, so that's it. Um, and when you're done, then after it gives you the orange juice, that was your money. So it goes back to its original state, which we don't know about states. We're going to learn in a second. Machine goes back to starting state. Okay. Now, what are the states of a finite state machine? So the idea is um, we're going to model this vending machine by how much money is currently in the machine. So we're going to, let's see, let's look at the model. Um, right? So we're going to have a number of states. Every state machine is going to have states. So we're going to have, in this case, I think 7 states. Um, we have 7 states. Called, you call them whatever you want, but I mean, this is how we normally just start at 0 and go up. So S0 for state 1, state 2, state 3, and we're going to go up to state 6. Now, what are we going to use these states for? It's up to the designer, which is us, although not really because um, the book did it. So what it is that it's the amount of money in the machine, where each state you have whatever the number is times 5 is how much money is in the machine, which is part of the reason we started at state 0, right? So like S0 is 0 cents in machine, S1 is 5 cents in machine, S2 is 10 cents in the machine, and so on, right? Until you get to S6. S6 would be 30 cents in the machine. You just multiplied it in the index by 5. So 6 times 5 is 30. So those are your states. And we don't need any more states than that because um, even if momentarily there's more than 30 cents in, we're just going to refund it as the next thing we do. So the machine never sits there with more than 30 cents in it. So we don't need a state for that. Um, so you have these states, and how the machine reacts is going to depend on what state you're in and what you do. Okay, so as you use the machine, you're going to be moving from state to state. So as you use the machine, the machine is operated. It will move or transition from one state to another. Now I'm not going to rewrite what we did up above. I'm just going to label the states now on it. So let's scroll up here and look at this example operation and see if we can label what happens. So pick a color here. Let's go green. All right, so we walk up to the machine, right? Now, when you walk up to this, the machine, of course, the machine is going to be in state 0 because we have not put in any money and probably nobody else left money in it. You don't usually get that lucky. Now, then what's going to happen is we put 10 cents in. So when you put in 10 cents, the machine is going to go from S0 to S2, right? Because S2 is the one where there's 10 cents in the machine. Now, then what happens is we put in 25 cents. Okay, so you put in 25 cents. Now you go from 10 up to 25. Okay, so you go, or sorry, you have 10, you put in 25, so you have 35 cents in the machine. Now, what we said is we're not going to have a state for 35 cents. We're only going to have a state for 30 cents, right? The highest it goes is 30 cents in the machine. So when we put this 25 in, we go from 10 to 35, we're going to be at S6 is what's going to happen. Okay. But what also is going to happen is we're going to go to S6, but also we're going to return 5 cents. So machine is going to output. This is not a state transition, so I don't know why I'm just kind of writing what I already wrote. Okay. Then you press the orange button. And now you press the orange button, and then the machine gives orange juice, and then the machine goes back to the starting state. So actually, all of this together here, these last 3 steps, is going to be where the machine is going to go from S6, which is when it had 30 cents, back to 0, right? That's where you spend your money, it goes back to the start. It goes back to the start, but it also spits out your orange juice. Okay? And so, again, over the course of the operation, the machine goes from S0 to S2, S2 to S6. It does a couple outputs. It outputs money and it outputs an orange juice. Um, let's say outputs orange juice, OJ. Um, and then it goes back to its starting state, and then you're done operating the machine. Okay? And so if you carefully define this machine, then you will know that there's no bugs in it, which is part of the reason these are used, is because you design it all on paper and you know every way there is to get from one state to another state, and hopefully that will, really minimize the type of bugs that you could have in your logic. Okay. Um, like if you were writing this in software, there could be a software bug where um, you know, somehow you ended up with negative money. And if you had negative money, then the machine just let you buy whatever you wanted, right? Something like that could happen. Whereas if you use a finite state machine model for this, then you only have specific states, specific allowed amounts of money. It will never end up in a state where there's negative money. It'll never end up in a state where there's more than 30 cents. So that means you wouldn't be able to trick the machine into thinking there was negative money or over 30 cents. And so, therefore, you'd be eliminating one type of bug that program could have if you were doing it in software. Okay. Now, there's different ways to represent the state machine, right? So there's one way where we use a big table, and we're going to do that now. And then there's another way that uses kind of a chart. So we're going to use what they call a state table first. So state table for the vending machine. Now, a state table for a large um, state machine like this, it's kind of a lot of writing, but it is what it is. Um, so here we go. So here's what we're going to have to do. It's going to be a big table. So we're going to have, first of all, we're going to need to keep track of the state, right? This is going to be the state that we're in. Um, then we're going to need to keep track of what the input is. But hold on, let me move this down actually. There we go. Um, then what we're going to need to do is we're going to keep track of the inputs. We go here and say inputs. Oh, no, no, that's not what I wanted to say. I wanted to say next state. All right. Um, and then you have your inputs, and the inputs are going to be the different types of money that you can put in. Um, so you could put in 5 cents, you could put in 10, you could put in 25. Now that's what you can put in, but you could also have an orange juice, um, or sorry, you can press the orange button, or you can press the red button, right? So those are buttons, okay? And so we have all these. Now, you need another copy of these though, because not only do we have the next state that we need to keep track of, but also the machine has outputs. And so you have to keep track of those as well. And so that's why there's kind of two sections here, one for next states and one for outputs. And so all this is going to give me my table here. We're going to need some lines. Let's make some lines. Do them purple. Come on, just make a straight line. That's all I want. Right, I just realized that I should have done that before cutting it. Um, Actually, I even realized more. I should do this whole thing completely. All right, so do that. Good enough. Now, what states can you be in, right? We know S0, S1. Um, how spaced out do I want these? S1, S2, S3. Oh, see, that's not going to work. Yeah, well, we can make that work, right? Yeah, we can do that. S1, S2, S3, S4, S5, S6. All right, we will have it spaced out. But then that means I need to extend these lines. I think I can do that if I go like this, duplicate, I got more lines. Fancy. All right. It almost worked. How do I erase? All right. Yeah, sorry about that. This is taking me too long. Okay, good enough. Okay, so we got this, and let me just recopy this. This is for outputs. All right. Um, so here we go. So what you do is two things. So we've got basically the left section and the right section for the next state and for the outputs. And you just have to think about what happens, um, when you do the thing that's in the box. What I mean by that is this. So like, let's say right here. So this spot right here is when the current state is S0 and you input 5 cents. So you put a nickel in. What happens? Well, if you're in state 0 and you put in 5 cents, then you should be moving to state 1 because state 1 is 5 cents, right? State 1 is 5 cents in the machine. So you put an S1 there. All right. But it's not just that one box that you have to fill out. You also have to fill out this box over here. This one and this one both have to be filled out because those are both when you have S0 5 cents, S0 5 cents, right? So this, you have to fill out this half of the table at the same time you fill out this half of the table. These are corresponding. So if you're in S0 and you put in a nickel, what does the machine output? And the answer is the machine outputs nothing. So we just put like an in there for nothing. Okay. Now the notation is up to you, right? For the outputs, in is output nothing. Um, OJ is going to be output orange juice. And then AJ is going to be output apple juice. All right. Um, So then what you do now that I've done this is we're just going to go through and fill out the entire table. So you just have to think about all of these different things here. So um, like right here, you're in S1. S1 is 5 cents, remember? And we put in 5 cents, then we should end up at 10 cents, right? If you have 5 and you put in 5, you end up at 10. 10 cents is S2. Right? Don't forget about these states up here, right? This is what we're looking at. S0 is 0 cents, S1 is 5, S2 is 10, and so on. So you do that. Now, what do you output when you're at 5 and you put in 10? Nothing, right? Um, Now, you don't have to do one box over here, one box over here. You can fill out a lot of this and then come over here and do this. But I just want to make the point that this box and this box are really kind of the same box. It's just we're writing them separately because we're keeping the state transition separate from the outputs, just to make it easier to write, basically. Okay, so if you're in S2, 10 cents, and you put in 5, you'll go to S3. If you're in S3, which is 15 cents, and you put in 5, you'll go to S4. If you're in S4 and you put in 5, you'll go to S5, which is 25 cents. If you're in S5 and you put in 5, you'll go to 30 cents, which is S6. And then finally, we get to the bottom here. When you're in S6, which is 30 cents, and you put in 5, what's going to happen? If you're in 30, you put in 5, you're not going to change states. 30 is the highest state. So it's just going to sit there at 30 cents. Now, what happens on the outputs though? Well, for the outputs, if you have 10 and you put in 5, nothing happens. If you have 15 and you put in 5, nothing happens. If you have 20 and you put in 5, nothing happens. If you have 25 and you put in 5, nothing happens. But if you have 30 and you put in 5, then actually the machine will spit back 5 cents at you, right? Because you're already at 30 cents and you put in 5. So if you're at 30 and you put in 5, you stay at 30 and it spits out 5 cents at you, right? So like it just doesn't let you put in the 5 cents. You put in 5, but it just comes out of the coin return. So it actually will output money at you. Okay, so that's what happens if you put in a nickel. So then you do the same thing for what happens if you put in 5 cents, or sorry, 10 cents at a time. So if you put in 10 cents at a time, if you're in S0, 0 cents, and you put in 10, you're going to go up to 10, which is state 2. And then if you are in state 1, 5 cents, and you put in 10, you're going to end up at 15. Wait, is that right? Yeah, that's right. Then if you're at 10 and you put in 10, you'll be at 20, which is S4. You can see a pattern here, right? Like this was S1, S2, S2, S3, S3, S4, S4, S5. So use the patterns to see if you make mistakes. But if you're at 15 and you put in 10, you should be at 25, which is S5. Then S6. And then what's going to happen here is, if you have, so this one right here was 20 cents and you put in 10, 20 and 10 make 30. So you have 30 cents. But then this is going to be if you had 25 and you put in 10, which is 35 cents. But remember, there is no 35 cents, so you just end up at S6 again. And same thing for the other one. If you're at 30 cents and you put in a dime, you end up at S6 again. And then you go, okay, well, what's the machine going to output? So the other table. So for the other table, S0 to S2, that's 10 to 20, nothing happens. 5 to 15, nothing happens. Nothing happens. Nothing happens. Nothing happens. So if you look here, this was this one, right? That's the corresponding row to this. So if you had 20 cents and you put in 10, then you just end up at 30, but nothing happens. Whereas if you're at 25 and you put in 10, right? 25 down here, 10 here, then you're at 35 cents. But you go to 30 and the machine must spit out 5 cents to keep you at 30. Okay? Last one here. So if you have 30 and you put in 10, you end up at 30 and the machine should spit out 10 cents. Okay? And so these tables here just have like this kind of thing going on. So let's do this last column hopefully relatively quickly. It's the last column, but the last column for money. So if you're at S0 and you put in 25 cents is going to take you all the way up to S5, right? 25 cents. Then if you're in S1, which is 5 cents, and you put in 25, you'll end up at 30, which is S6. And then at that point, the rest of the column is just going to be S6, right? Because um, if you start out with 10 and you put in 25, you'll have 35, but that's going to be state 6. So these are all going to be too much money, all S6. Okay? And then if you look at the outputs there, for the outputs, well, the first output is going to be S0, which is 0, to 25, which is 25. We don't need to output anything. Next one is going to be S1, which is 5 cents. 5 cents plus 25 is 30. We don't need to output anything. The next one, though, is going to be 10 cents total to start, add 25. So this one right here, we're at 35, which means we need to spit out 5 cents, right? If you end up at 35, you spit out 5. And on the next one, if you are at 15 and you put in 25, 15 and 25 is what, 40? So you need to spit out 10 cents and you'll end up in 30. If you're at 20 and you put in 25, that's 45 cents, which means you need to spit out 15. And this will be spit out 20 and this will be spit out 25. You can go through those and just verify that those are correct, but that should be how it works. Okay, now we have the last columns. So the last columns are O and R. So these are buttons, right? So these are buttons. So what's going to happen when you press the button, basically? And so most of the time on a vending machine, if you walk up to it and you press the button, nothing happens, right? Vending machines only do something useful when they have enough money in them to actually give you something, right? So pressing the button's not going to do anything most of the time. And what that means is that there's not going to be a state transition there. Think about it, right? If you have S0 is 0 cents. So if you walk up to a machine with 0 cents and you press the button on it, you're still going to have 0 cents, right? Which means there was no state transition. It had 0, it still has 0. Same thing for the red button. Going to do the same thing. Now, if the machine has 5 cents, right? S1, 5 cents, and you press the button, nothing happens. So nothing happens, so we stay in the same state. Now, if there's 10 cents and you press the button, nothing happens, stay the same. If you got 15 cents, what happens when you press the buttons? Nothing. So S3, S3. 20 cents, nothing happens. 25 cents, you press the button, nothing happens. All right, finally, 30 cents, something happens. So when you press the button with 30 cents already in there, if you've already got 30 cents and then you press the orange button, you're actually going to get orange juice, right? But this isn't where you write orange juice. This is where you write the state transition. What happens when you press the button, right? Where's our example? If you've got 30 cents in and you press the button, you actually need to go back to the original state. So this is where you go back to the start at 0. Now it doesn't just go back to 0, right? It also spits out orange juice. But you say spits out orange juice over here, right? This is where you say that. All right, now let's look at the output. So the output for the buttons, when you press the button, is going to be nothing most of the time, right? We talked about that. So most of the time, you press the orange button, nothing happens. You press the red button, nothing happens because you didn't have enough money in. Not enough money, nothing happens. Not enough money, not enough money, not enough money. 25 cents, not enough money. but you get to the end, and the last row is where you had 30 cents. So right here, this is where you had 30 cents in, and you pressed the orange button. So what do you get? You get orange juice. Maybe I'll even write in a different color. You get orange juice. And if you press the red button, you would have gotten apple juice. So what's happening is, right, you spit out the apple juice, and at the same time, you set the state back to 0 because it takes your money when you get the apple juice. Okay? So you do all this, and this is going to be a great big table for explaining to you exactly how this vending machine works. And so if you write some code that just allows state transitions, right? You use a little array for what state you're in, or even just a variable that can only be allowed to have 0 through 6 numbers on it. And all you got to do is program all these state transitions and these outputs, and you'll have a vending machine. Okay. Now let's see here. Uh, Trying to decide what I have enough time to do right now. I think what I want to do is just hit you with the definition, and then we'll stop, and I'll have a second part to this up today as well. So let's see here. So let's hit you with the definition. Definition. So this is going to be what you need to really have a state machine. So a finite state machine, which so they're going to write this way. M equals, and then they say, what is in it? S I O F G. Okay, what is all this? Um, so it consists of, um, so what are these, the S, I, O, F, and G? So what it consists of are S. S is going to be a finite set of states. You know, like we had S0 through S6 in the example. Okay, then we had I. What are I? What are I? What's I? So I is going to be um, the input alphabet they call, which is just the list of inputs, possible input. Um, that's you know, a list of the possible inputs. All right. Now we got O. That's going to be the output. Do they call it an alphabet? Probably, huh? Um, that's going to be the list of possible outputs. And then we got these F and G. So F and G are probably what confused you. If you were looking at that, you probably could say, oh, S for states. Yeah, got it. Um, so what F and G are essentially, these are going to be the tables, right? So one of these is F and one of them is G. So this is F. This is F, basically, the state transitions. And this is going to be G, the outputs based on the inputs. Okay, so let's say this. F is a um, transition function that assigns assigns. I spelled assigns wrong. Um, to each current state and input and output state, right? So you had to know, right, in order to get the, like, in order to know what was happening here, you had to know the input state S1 and you had to know the input 10. So you had to know the current state and the input. So um, you have a current state and an input, and it tells you the output state. So that's that entire blue table up there. Um, right? And then you have G. G is going to be exactly the same thing, but it's going to be, what do they call it? Output function. Okay, that makes sense. Output function that assigns uh, each current state and input again, right? That was the same. Um, and output. All right, actually, why did I say output up here? What did I think I used the wrong word? Yeah, they just say a new state, just to make it not repeat the word output there. All right, so and then that was the what was it, green part of the table? And I forgot something in here, probably because I ran out of room. But one last thing, S0. Um, so you also need a starting state, right? When you start up a finite state machine, you need to start in a particular state, and that's just going to be the initial state. Right? That's what the machine starts up in. Okay? And so that is everything you need to define a finite state machine. And we actually did it up here um, just by, we have an initial state S0, we have all the state transitions. So we have we have F right here, we have G right here. This is our possible state. So this is S. These are our possible inputs. So that is I. This is also I. And then in order to see our outputs, we didn't list them, but if you look here, you can see the possible outputs are nothing, 5, 10, 15, 20, 25, OJ, AJ. So all of these are possible outputs. Um, and also the green is function G. So that's everything you need for a finite state machine. Now, this is not the only way to look at it. You can also make like a pretty graph of it. We just simply don't have enough time at this moment in time, so it'll be in the next video. Okay, talk to you guys later. Next video.